would have to equal to 0, right? Because the neoclassical growth model says we're going to have very elastic supply of capital. So capital is going to end up back to the same old return. So immediately we know delta W equals delta TFP over S. Right? Yeah, we're going to know that. So we've already determined the price side. So the growth in W, the growth rate in W, has to be equal to the growth in TFP divided by the share of labor. Okay. Now you might say, well, which share is it if the share of labor is changing? It's going to be some kind of average share over that whole period of time. It's going to still happen. All right. What else? What's going to have to be equal to 2? What's going to happen to delta K over L? In order to get delta R equal to 0, what are we going to need to do? Well, we're going to have K go up enough to basically get a delta R equal to 0 when delta W is equal to delta TFP divided by SL. So what's going to happen is, the greater the elasticity of substitution between labor and capital is, and the greater the bias in technology is for capital, the more we're going to have to increase the capital stock. Because we're going to have to increase the capital stock enough to get productivity down. Let me show you with a graph. Maybe that's the easier way. Think of it this way. Put K over L. Put Y over L. In a curve that looks like that, right? So this is the value marginal product of capital. Yeah. That's the value marginal product of capital. Schedule of capital. Oh no, let me put R. That's the value marginal product. Now, at a given level of K over L, this area is Y over L. I'm sorry. Right, that's Y over L. Right, because that's the total amount of output being produced by per worker. Right? This is the marginal product schedule of capital. The area under that demand curve gives me K over L, and Y over L. So now what happens in the short run? In the short run, this curve shifts up, and we go up to here. And depending on the bias, determines how much of this is paid to capital versus how much of it goes to labor. Because capital is going to get the increase in the height of this curve as its value marginal product. And labor, right? So this goes to K, and this goes to L, right? L gets the surplus above the line, and K gets paid its marginal product. Okay? So you understand that? Now what happens in the long run? Well, in the long run, we move out to here. So L is going to get all the productivity growth, plus whatever we gain by increasing capital. That's basically the picture that we have. So that's the picture that will generate the long run growth. Now, when technology is biased in favor of capital, or technology, or the elasticity of substitution is bigger than 1, then labor share is actually going to fall because capital is going to go up so much, they're going to collect more. But the key is that increasing capital is actually giving more and more to labor over time. That's the important side of it. Do you understand how that works? Just look at this 20. Right? There's delta W minus delta R. And substitute in sigma, this minus delta V. Add in here, delta TFP equals SL delta W plus SK delta R, I'm sorry, delta W minus 1 over sigma delta K minus delta L minus delta V. So this is delta W. So delta W equals delta TFP plus 1 over sigma delta K minus delta L plus delta. And that's probably the formula we should start. So that says the growth in the real wage is the growth in TFP plus some effect of capital deepening plus technological bias.
Where did the share of capital go with the everything?
Oh yeah,
except for-
that's sorry. We got a SK here. That's our capital deepening here. Let me rewrite that. Just like the capital deepening formula we had last time, delta W equals delta TFP plus SK delta K minus delta L plus delta V. All right. So this is the growth in the real wage rate that we're going to see in the economy. This is the growth in TFP. And this is the growth of capital deepening that we had from our earlier formula. And then this is technological bias.